We have a consortium of industrial and academic partners. From the industrial side, we have ABB, which I represent, which we are a major SCADA vendor, deliver systems all over the world. We have a major utility from E.ON in Germany. We have two SMEs. Aston is a system integrator in Hungary, and MML is a small company that evaluates the value of electricity. They make models for the value of electricity. And we have academic partners. We have the Royal Institute of Technology in Sweden and the ETH in Zurich, and we also have actually Berkeley as a half member and Maryland included, although they don't get no contribution from EU, so they are there anyway. So what we want to do in this project is to come from attacks. So we will make, I come back to this, but we come all the way from the attacks. How could the attacks impact on the computer system? How could the computer system impact on the power network? And what will be the social costs if you have a power outage? So we will make models. We will make a model from the SCADA system. Okay, maybe I should start here. What we start with doing an attack inventory. So what we are doing now is looking on different types of attacks that could be possible for this. And we use two methods for this. We use literature standards and literature standards, which we can use for attacks, but we also interview a lot of experienced experts in the area of power system control. So we are building an attack inventory, and we have now in the order of 100 types, but I will not say a type. So we have 100 attacks, and we can group this together to maybe 25, something like this, types of attacks that we will do. Then we will make models of the SCADA system itself. We make models of the power grid. This is known technology. Power grid models, there's a lot of those around, so there's not no strange thing there. But what we will do in the project is also make these society models. But if we start a little bit on the attack, we will formal attack trees. And I give you just one simple example. Maybe we have an attacker that want to cause, if you look in the top, cause social damages for a certain number of dollars. He believes he can do this by initiate load shedding, so that the companies that are providing power must shed some of the loads in order to stabilize the network. And then how can you do that? You can decrease the power supply from the high voltage network. How can you do that? You can destroy the transformer, a certain transformer. And that I want to say, to destroy physical assets is outside of the Viking project. Our project is focused on cyber attacks. But let's look on the cyber attacks. Maybe you can get access to the communication network. You can introduce a false telegram, and this telegram simply opens the breaker. The SCADA system sends telegrams to the substation that opens breakers. They are sent in encrypted messages using standards that you find on internet. So if you get access to the network, you can fairly easily introduce a false telegram. Maybe you are you want to be even smarter than that. You can fool the operator because you have an operator in the control room, and if you present him with false information, he can then make the false decision, open the breaker, and you have these damages. So we will model these attack trees, attack types, as I talked about, in this type of formal languages. And we will apply these formal attack trees on this model. So we can basically take an attack and run it through these model systems to get out the cost for society. This is our hope when the project is ready. But